Over the last few years, the Department of Meteorology and Atmospheric Science has welcomed several new faculty members. And right now we're taking some time to introduce them to you. Tonight we check in with Dr. William Bristow, who joined the department in 2020. Thanks for visiting with us, Bill, and welcome to Weather World.
Thanks, John. Appreciate it.
Hey, you came to Penn State from the University of Alaska Fairbanks. Now that's quite a relocation. What's been the biggest adjustment for you moving to central Pennsylvania?
It's definitely a relocation. It was more than 10 days drive. But I have to say, and people are going to think I'm crazy, the weather here is much worse than it is in Fairbanks.
What do you mean by worse?
Well, sorry. So I, people think of Fairbanks as being a cold and dark place in the winter, and it is. But it's a very nice cold. We have very dry winters and no wind. And I am a ski enthusiast, or cross-country ski enthusiast. So I spend a lot of time outdoor skiing there. And here, the winters are a little gray and it's damp cold, and it's just penetrating sometimes.
Yeah, I was surprised, I must admit, to see that here in central Pennsylvania, we get 3 times the amount of liquid precipitation than Fairbanks does. I didn't realize it was quite that dry.
Yeah, so it's very, very dry snow. This year there were, well, most years it's something like 60 inches of snow fell in the winter course of the winter, maybe 3 feet on the ground at a time, but it's the water content is nothing.
Yeah.
It's very small. Yeah.
Well, we rarely have a 3-foot snowpack here in State College. Now, your background includes a bachelor's in electrical engineering and applied physics, then a PhD in space physics, and now here you are in a Department of Meteorology and Atmospheric Science. How does all that fit together?
Well, I guess it's a long story, but so as an undergrad, I was studying electrical engineering and applied physics concurrently, and was recruited by a space physics faculty member to work on some electronics. And I guess got fascinated with the discipline. And I was in Alaska, and it was studying the Northern Lights and things associated with that. And a lot of that study is done using radars. It's a remote sensing, field. You have to look at things in space from the ground. So a lot of optics, a lot of radars, and electrical engineers do radar work. So it's a good fit there. Now, as far as meteorology, it's more atmospheric science than meteorology, and it is a good connection. There are good connections between what happens on the ground here and what happens up in space.
Right. And, you're interested in phenomena that take place in the upper atmosphere beyond where we tend to focus on weather world. How high up are we talking about, and what's the atmosphere like at those altitudes?
I study the ionized part of the atmosphere, and there's significant amounts of ionization starting at about 80 to 100 kilometers. It depends on time of day, time of year, time of the solar cycle. And so pretty high up. And from there, space physics really takes off from there and goes out to the sun. But my work is focused mainly in the near Earth space regions. So.
Okay. And, let's talk a little bit about the specifics of your research and your interests. So many scientific projects have a great acronym, and much of your research centers around a project called SuperDARN, which has to be one of the coolest acronyms I've ever heard. Tell us about SuperDARN.
Sure. It has a history. So about the time I graduated from my PhD, there was a previous project called DARN, and DARN stands for the Dual Auroral Radar Network. And it was a precursor to what is SuperDARN. It used a slightly different kind of radar system. So it's a network of radars. And super is just to mean it's a bigger and better than the previous incarnation.
Gotcha. And so what are some of the measurements that SuperDARN can make and the phenomena it helps us study?
So it's looking at the upper atmosphere, the ionized plasma is what we call it. And it's tracking its motions. The radar systems, they transmit a signal that scatters from the plasma, and that plasma is influenced by electric fields that are imposed on the upper atmosphere from space. And those electric fields cause a motion, and we want to map those patterns of motion in that plasma. And that's used for a number of purposes.
So you mentioned it's a radar system. This is a network of radars, correct? And where are they located?
So yes, it is a network. So the N in SuperDARN is network, and it's a large international collaboration. We have participants from something like 10 countries actively operating radars, and a number of other folks using the data and participating in other ways. The radars are focused on the northern and southern high latitude regions. So the original network was across central Canada and through over to northern Europe. We have added radars at higher latitudes up in northern Canada, and now at lower latitudes across the central US and actually in Japan and in Europe now. We also have in the southern hemisphere. So I have responsibility for radar systems at McMurdo Station, Antarctica, and South Pole Station, Antarctica.
I'll bet those make for some great coordination when you're trying to do a conference call with your collaborators. Hey, Bill, we're just about out of time.
Sure.
Thanks so much for joining with us, and welcome to the department.
Okay, thanks, John. Good to talk to you.
And we will be back in a moment with a recap of the short range forecast.